Hi, ho, students. It's Mr. Kaczynski looking for Pythagoras Investigation 4 Checkup Solutions. We're going to start off with some Pythagorean theorem practice here. Find the length of the third side of this right triangle. Round to the nearest tenth if necessary. Here's the Pythagorean theorem. We've shown this in various ways, but I'm going to rely heavily on the algebra here using the formula. Alright, so remember that in the Pythagorean theorem, A and B represent the legs and C is the hypotenuse. That's the side across from the right angle. So here's the right angle. That's the side across. That makes X the hypotenuse in this case. So here's the way we're going to plug things in. 1.6 squared plus 8.3 squared equals X squared. When we add up those two squares, and I used calculator a lot for that, 1.6 squared plus 8.3 squared, that'll give you 71.45, and then if we take the square root of that, we'll get our answer. So the square root of 71.45 is about 8, oh boy, square root of 71.45 is about 8.5. Little shortcut bonus for watching the video. Watch, you could just do the square root of 1.6 squared plus 8.3 squared, and you only have to hit enter once and you'll get the answer. So, this finding 71.45, if we're just going to round anyway, use the calculator. There's the entire Pythagorean theorem right there. All right, moving on. So this time, the unknown leg. Okay, we don't know a leg. Okay, so we know the hypotenuse. Again, because the hypotenuse is the side across from the right angle. All right, but we don't know both of the legs. All right, so a squared plus b squared equals c squared. This time c is 7. It really doesn't matter where you put the x and the 4, as long as you put them in for either a or b. All right, so 4 squared is 16. 7 squared is 49. You subtract 16 from both sides and then take the square root of both sides, and the square root of 33 is 5.7 about. Again, let me show you in the calculator, nice little shortcut. The square root of the hypotenuse squared minus the legs squared will give us the length of the other side. Ooh, there it is, 5.7. So you don't even need to really know this 33. If you really know the theorem and you know how to use the calculator really well, there's some shortcuts. Perimeter of this triangle. Well, before we can find the perimeter, we got to know that third side. So we got to find that hypotenuse. 36 squared plus 48 squared equals c squared. That's 1296 plus 2304 equals c squared. So that side, that square off the hypotenuse would have an area of 3600, and the third side would be about 60 yards. The perimeter is the sum of the three sides, which is 144 yards. So just that added step of adding the three sides together to get the perimeter. Area. Okay, again, to figure out the area, we need to know this length, okay? We actually don't need this 26 to find the area. However, we're going to need it to find that third side. So here we go, Pythagorean theorem again. This time, we know the hypotenuse is 26. So you get 100 for 10 squared and 676 for 26 squared. Subtract 100 from both sides. Take the square root of both sides. That means this right here is 24 miles. Okay. So this side's 24 miles. All right, area is 1/2 base times height. The base is that 10. The height is the 24 we just found. 10 times 24 is 240, and half of that is 120. So 120 square miles is the area of that triangle. It's a big triangle. Derek just went down the slide at the playground. He walks 1.8 meters to get from the end of the slide back to the ladder. Then he climbs 2.1 meters to the top of the slide again. How long is the slide? If necessary, around to the nearest tenth. Okay. Well, I think we're working under the assumption that we've got a slide, as I do here, that is a right triangle. Okay, so again, I'm working under the assumption that that's a perfect right angle right there. So, all right, so he walks 1.8 meters to get from the end of the slide back to the ladder. So this is 1.8. He climbs a 2.1 meter ladder. We're trying to find the hypotenuse here. So we got Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. 2.1 squared is 4.41. 1.8 squared is 3.24. You add those together, you get 7.65. That means the length of the slide is 2.8. So I used a lot of calculator. A lot of people will like 2.1 squared and write it down, and 1.8 squared and write it down. And then they add them, the 4.41 and the 3.24, and you write it down. And then you take the square root of 7.65, and you get the length of the slide, about 2.8 meters. Nice little shortcut, but you can't really use this until you really get a Pythagorean theorem, is to take the square root of the leg squared plus the other leg squared. There it is, same answer. All right, moving on to the next part here. Rational and irrational numbers. Okay, classify the following numbers as rational or irrational. Well, that is a repeating decimal. 35.65 repeating. All repeating decimals are rational, because I can write that as a fraction. Specifically, that fraction would be 35 and 65/99. See? There it is, 0.65 repeating. All right, 17 over 22, that's rational. It's written as a fraction. The very definition of rational numbers is any number that can be written as a fraction. Okay, it's rational. Even if you took the time to enter it in, which is silly because it's already a fraction, you'll see that it is a repeating decimal. So all repeating decimals are rational. Square root of 14 is irrational. The only way that we're going to do a square root of a number and have it be rational is if that number inside the radical was a perfect square. 14's not. 36 is. So the square root of 14 is a non-terminating, non-repeating decimal. That's irrational. Square root of 36 is very much terminating. That makes it rational. 2/3. Again, it's written as a fraction. That means it's rational. Write these in decimal form. Okay, well, most people probably just use the calculator, so I'm going to use the calculator too. 6 divided by 25 is 0.24. Okay, now the other way you can think about it is 25 times 4 is 100. That means this thing's going to end at the hundreds place, tenths, hundreds. And 6 times 4 is 24. All right. 10 divided by 8, that's a terminating decimal. These are definitely level 1 questions, guys. 1.25, there it is. All right. 8 divided by 11, that's going to be a repeating decimal. So the thing is, we got to identify which repeats. I did have some people write that all the way down to the 3, which is wrong. The calculator's not even right. This is not equal to 8/11ths. So it's 7, 2, 7, 2, 7, 2, 7, 2, 7. That's a 2 because this was a 7 that caused that 2 to be rounded up to a 3. All right, so we're going to go with 0.72 repeating. It's the 7 and the 2 that repeat. And then the last one, 3 divided by 22. That's 0.136363636. That's a 3, and the fact that there's a 6 coming behind it caused it to be rounded up to a 4 on the calculator. So it's the 1 and then 363636. So 1 doesn't repeat, the 3 and the 6 do. Notice that that vinculum, that line, that repeating line, is above just the 3 and the 6. Fill in the blanks to make this statement true. Okay. Well, a lot of people probably have it memorized that 0.75 is 3/4, but I'm obviously asking for more than that. Okay, so the next thing I thought people would go to was, okay, well, it goes to the tenths place, the hundreds place. That means that this number on bottom is 100. And the number on top is the 75. So 75 100ths. There it is, 0.75. Math, enter, enter, turns it into a simplified fraction. It is 3/4, but you had to fill up all those boxes, and 3/4 doesn't work so well. All right, this is the same idea. This goes from the tenths place, the hundredths place is where the 7 is, the 8th place, the 8th is in the thousandths place, and then we'll just put 578 on top. There we go. Fill in the blanks to make this statement true. Okay. Well, if it's 2 digits repeat, then it's those 2 digits over 99. 36 divided by 99 is 0.36 repeating. There it is. So if you use the calculator, you just 0.36 math, enter, enter. You know, it gives you 9/25, but again, I didn't put 9 on top, so. Which of the following would definitely be rational numbers? Circle all that reply. A terminating decimal. Any number that terminates is definitely rational. Rational. Repeating decimals. Any repeating decimals, they are also rational. Non-terminating, non-repeating decimals are irrational. Okay. Now, the reason that terminating and repeating decimals are rational is that they can be written as fractions. Okay, so any number that can be written as a fraction will turn out to be terminating and repeating. That makes it rational. The square root of a perfect square is also rational. We saw that in this quiz. Square root of 36 is 6. Square root of 25 is 5. 36 and 25 are perfect squares. But the square root of a number that is not a perfect square will be irrational. And lastly, we're going to rewrite these in order here, okay? Well, just, you know, to kind of get things straight, from least to greatest, 4 3/4 is smaller than 5.4. The question is, and I know the square root of 24 is less than the square root of 32. Let's see, 5 times 5, 5 being more than 4 3/4 and less than 5.4 would be 25. So this is really close to, well, it's definitely, I mean, it's less than 5. It's really close to 5. I mean, if we take a calculator, we can check it out. I didn't take the calculator away from you, but you should be able to do this estimation in your head. Yeah, see, it's really close to 5. So I'm thinking, and then let's see, 6 squared is 36. 5 squared is 25. This is really close to 5.4, so maybe the mental math kind of runs out on us a little bit. So that's 5.65. That's more than this. So there's our order. All right, so if you use decimals to estimate, you know, where they should go, definitely when you're reordering them, you should put them in the right form. So there's our final answer. If you got questions, let me know. Hopefully this was helpful to you, and let me know if you're working on IXL or doing other extra practice and you got some questions. Have a great night.